Hi, everyone. Thank you for that intro, and thank you all for being here. Um, so, sorry. I want to start out by showing a course that many of you might be familiar with, Design and Analysis of Algorithms. It's a cornerstone for any aspiring computer scientist. But there's a catch, the cost. For students at Stanford University, as well as many other universities, this course costs $4,000 to $7,000, a steep price that makes this vital knowledge inaccessible to many who can't afford it. Now picture this. This exact same course is available on edX, even offered by the same university. And the content, the curriculum, it's almost identical. But there's one significant difference. It's completely free. Sounds fantastic, right? But there's a hidden cost that's not reflected in the dollars. This stark contrast in pricing primarily stems from one key factor: the lack of teaching assistants and adequate support in this free course. This leads to many students enrolled in the online course prohibited from acquiring the crucial educational support that could really supplement their learning experience. Imagine hundreds of students all trying to grasp complex concepts, but with very, very limited guidance. So this disparity in educational assistance caused my team and I to confront a pressing question. How exactly can we bridge this gap? How do we provide quality educational resources and support for students who can't afford the expensive university courses? Hi, I'm Aashika Vishwanath, a sophomore studying computer science at Penn. And this past summer, I had the opportunity to compete in the Carnegie Mellon University Generative AI Hackathon with 4 other team members. Our product, ChaTA, an in-house LLM teaching assistant, not only won the hackathon, but also earned $20,000 in prize money. While this was certainly a highlight, I think the real win lay in the impact of our solution, as well as the wealth of learning that the experience brought. And that's what I'm excited to share with you today. So going back to the original problem statement of students in expensive university courses having access to all these educational resources as opposed to their online course counterparts, AI systems have tried to address this gap in the past. For example, Georgia Tech built out Jill Watson. However, this rule-based system severely lacked depth because when a student would ask any question outside of the bounds of what it was programmed to answer, the bot would not be able to answer those questions. Then we had advancements such as ChatGPT and GPT-4, but these are not customizable. So any student throughout the world asking a question would get generally a similar response. But if a student had a question on a specific lecture like slide or a professor's material, they would not be able to get that answer from a system such as GPT. And then platforms such as Conmigo don't have this idea of continuous improvement, where the user can provide feedback to the model and the model would incorporate that. And this is where ChaTA steps in. An LLM-based teaching assistant, it's designed to adapt, learn, and grow. So ChaTA has 3 main components. The first is information retrieval on a vector database, and then fine-tune pre-trained LLaMA2 on question-answer data, and finally, reinforcement learning with human feedback. So let's break this down a little bit. So the first part, information retrieval on a vector database, is where the LLM is trained on the specific course material that the student is taking. So we did this by scraping a couple CMU courses, feeding this into a database query, and every time a student asks a question, the question would go along with a question embedding, so it provides some context to the LLM as to what exactly it should answer in terms of the professor's lecture slides, the textbook, etc. And so instead of giving a generic answer to the student, the answers will align perfectly with the material that the student is learning from. And next, there's fine-tune pre-trained LLaMA2 with question-answer data. So LLaMA2 is an open source LLM that was released by Meta just a few days before we entered this hackathon. And so instead of just using that as is, we really wanted our LLM to understand the nuances of a teacher-student dynamic and the most effective ways to produce responses that align with learning principles. And so by feeding it data from educational resources such as Piazza and Ed, we were able to effectively replicate a real human TA experience. And finally, there's reinforcement learning with human feedback. So this is where the model asked the student what they thought of the TA's response, and we adjusted the model accordingly on the back end. And this provided the most affordable experience closest to a human TA while still keeping students in the loop to improve the reward model. And so all of these different components align pretty well with the hackathon judging criteria, which is safety, societal impact, improvement of quality of life, creativity, and technical advancement. And here's also a mention of the judges. So I think that my diverse education through Penn, spanning both pretty technical classes as well as classes in entrepreneurship and venture capital, allowed me to contribute to my team through both a technical standpoint and a business standpoint. So on the technical side, our data was pretty unstructured, including text, audio, video. So I was able to perform some feature engineering using techniques like text normalization, document parsing, transcript processing. I also built out our front-end interface using JavaScript, HTML, and CSS. And so here's, I guess it's not playing on here, but this was a demo of like our preliminary front end. And it was a cool experience to kind of bring all of the work that we did on the back end to the limelight of a user to interact with. On the business side, I created slide decks that told powerful stories about our unique value proposition and our purpose for building this. I also was able to cater our presentations to different kinds of target audiences of over 100. It was a cool experience to kind of be involved in the pipeline of our project at different stages, beginning from the feature engineering to building out the front end and throughout the middle, telling the narratives of why we were doing what we were doing. I was also the youngest on our team, so my teammates were PhDs and master's students from universities like CMU, Cornell, and Texas A&M. And I think being an undergrad at Penn really allowed me to kind of bring in the perspective of what it means to kind of have a transformative TA and characteristics that we could incorporate into our LLM of what makes a TA so strong. In addition to diversity in age, our team was also diverse with respect to gender. Most of the other teams in the hackathon were dominated by males, but our team had 3/5 females. We were also diverse in terms of ethnicity, location, as well as the area of academic expertise that we all came in with. And I think this diversity really propelled our approach and allowed us to kind of stand out amongst our competition. And it also shows the value of inclusivity in driving these technological innovations forward. And so the impact of our model was certainly significant. So our LLM didn't hallucinate, meaning it didn't make up information, and this was because it was trained on a specific knowledge base. Hallucinations are a major concern in LLMs in industry today, so this was definitely a great step forward. Our model also cited references, and this dramatically increases productivity for LLM trainers because they're able to see exactly where the LLM got the information from, and this also helps with debugging and error tracking because it's easy to find the source of a potential issue. And lastly, but maybe most importantly, our model rewarded good pedagogy, which is basically like learning principles, teaching style, through supervised fine-tuning as well as reinforcement learning. And so all of these components really helped our model, ChaTA, not only become a more effective TA that helps students, but also be able to learn and grow on its own. And so the journey of ChaTA is far from over. We're gearing up for beta testing to refine our model on real-world feedback. We're also exploring models such as Frugal GPT, among others, to kind of help it answer more complex queries more efficiently. We're building out a diverse set of reward models to enhance ChaTA's learning algorithms. And so all of these steps kind of help ChaTA continue to evolve as a more empathetic and effective educational tool for all kinds of students. ChaTA is more than a tale of technological innovation. It's a narrative about how diversity in thought and background can break down long-standing educational barriers. And I think this experience really reaffirmed my belief in the boundless future and possibilities for AI, specifically Gen AI, in education. And I think we stand at the threshold of redefining these educational possibilities, making strides towards a world where quality learning is accessible to everyone. Thank you.